So we solve systems of equations by graphing, but like we saw and talked about in the previous lesson, graphing is not the best method because if your answer is, a decimal answer, not an integer, it could be very hard to figure that out via the graphing, exactly what it is. Also, graphing is very time consuming. Also, you need to be very neat about it. If you graph your line without a ruler or you're sloppy, you might say the answer is something different than it really is. So we're going to talk about solving systems of equations by substitution today. You can try the warm-up on your own. With substitution, what you are going to do is you will have two equations in your system. You could have more, but we're focusing on two. You will solve for either x or y in one equation and circle the other side. So if I look at this example system right here, y equals, so y is already solved for here. You could use the second one as well, but I'm just going to look at the first one. Y is already isolated. Great. Then I'm going to circle the other side of that equation. And what you do is you substitute the circled half of the equation into the second equation for the variable you solved for. So y is equivalent to 3x. Then in your second equation, take that 3x and put it in for y. Instead of writing y, write 3x, okay? You could do this the other way. You could take x minus 2 for this y and put it into the first equation for y, but I'm gonna stick with normally we look at the first one and put it into the second. Then you have a new equation. So I would rewrite this as, instead of writing y for this, I'm gonna say, well, that's 3x. And that equals, and I'm keeping this, x minus 2. This is your new equation. So solve that new equation. You have one variable in one equation. So if I solve this, I would subtract x, and I would get 2x equals a negative 2. And I would divide by 2, and I get x equals a negative 1. Now, step number 4, substitute the value into one of the original equations. I have found that x is equal to negative 1. So I'm going to use this, but I'm going to put it into one of our original equations here. It does not matter whichever one you want. I think the first one looks a little easier than the second one. So if I take y equals 3x, but now I'm going to put in what I found for x. X is equal to negative 1. So I'm going to say y equals 3 times a negative 1. Substitute that in, and I get y equals negative 3. Step number 5, we just solved for the other variable. Step number 6, write it as an ordered pair. So negative 1 comma negative 3 would be your solution. Remember, you can always check this. Plug that point back into your original system. If I plug in 3 times negative 1, I would get a negative 3. If I plug in negative 1 minus 2, I would get a negative 3. So if I showed that check, it would work in both equations. So let's try a few more of these. Remember, today we're actually, the first day of this lesson, we're already going to have one variable isolated. So you really won't have to solve for it, you just have to identify it. Tomorrow, we will look at solving for it. So let's look at example 1. We can see that y in my first equation is already isolated. It's already alone. Take that x plus 1 and circle it. Everywhere that you see a y in your second equation, you will replace it with what y equals. So you will replace that y with x plus 1. So I'm going to substitute this in for the y in the second equation. So I will have 4x, I'm writing my second equation, plus, and I'm going to put in x plus 1 instead of y. I'm using parentheses just to show that substitution. In some cases, you will need the parentheses. You'll see one of those, but in some cases, you won't. Here, these don't really make a difference, right? So I substituted it in. Now I have one equation with one variable. I'm going to solve that new equation. So we're on step 3. If I had 4x plus x, I would get a 5x plus 1 equals 6. Solve this. You know how to do it. Subtract 1 from both sides. Divide by 5 on both sides. And I get x equals 1. Now, I'm going to take that value, this is step number 4, and I'm going to plug it into one of the original equations. It does not matter which original equation you use. I look for the easier one. The first equation has less stuff than the second equation. So the original equation is y equals x plus 1. I'm going to put this value in for x and solve it. So I have y equals 1 plus 1. So y equals 2. Now your system should have an ordered pair solution. So these two pieces need to go together to make my ordered pair. The ordered pair that works would be 1, 2. Remember that you can check it. Show your check by plugging it back in. I'm going to do the check in my head just due to time, and I do see that it works out. But show the check so that so that you can make sure that you are correct. All right. Example 2. Again, looking at your equations, you could see that y is solved for in the first equation, and actually y is solved for in the second equation as well. It does not matter which one you use, but remember, solve for one of them. So if you happen to see the second one, y equals, circle that, then I could plug this second piece into my first equation wherever y is. Remember that y is equal to this. So everywhere that you see a y, you can replace it with 2x plus 5. You, again, could do this the other way. You could say that y is equal to, you could say that y, if you look at the first one, is equal to x plus 3. So I'm going to plug that into my second equation wherever you see a y. Both ways will get you x plus 3 equals 2x plus 5. If you substituted the other direction, you would get 2x plus 5 equals x plus 3. Now you have one equation with one variable, so you can solve. Get your variables together. Remember in chapter 2, I always talked about putting your variables on the side where there are more. So there's 2x over here. I'm going to subtract this x to get it over there. Now I would want to isolate my x. Once you solve for one of the variables, you're going to take that value, this is step number 4, and you're going to substitute it into one of the original equations. It does not matter which original equation you use. The first or the second will be fine. So I think the first one looks easier. So I'm going to take that first equation and I'm going to put this in for x. Now you just solve it. Final step, make sure you put it together as an ordered pair and watch the order. X is -2, so x goes first. Y is 1, so y goes second. Also, make sure you check your answer by plugging it into the original problem. Try example 3, pause the video, then press play to go over it. Okay, so here's example 3. The first equation is already solved for x. So we can take what x equals, which is 2y minus 4, and we can put that in for x in the second equation. So that's what I did, and that's why this is right there. Okay, perfect. Now I can solve. I took 2y minus 4 and put it in for x, and I can see that I have the 2y and the 8y together on the same side. They're already together, so you can combine them and get a 10y. 10y minus 4 equals 16. And from there, you solve like you would a regular equation with one variable. In this case, we solved for y, and I got 2. Now I plugged 2 in for y into my first equation. Remember, it could be either the first or the second. I just look at which one has smaller numbers or fewer negative signs to make it a little easier. Make sure you show your check step. So when you plug 0 and 2 back in, notice that x is the 0. So I put that first. Y is the 2. So I put that second. It should work in both equations. Okay, so last example for today, and this one's going to help you with some challenging problems on your homework. Again, same process. So I can see that y equals x minus 4. Y is already isolated in the first equation. I'm going to plug x minus 4 in for y in the second equation. The important thing to notice here is that it's a minus y. There's a negative sign out front. So guys, when you do your substitution, use parentheses. I would have negative, and then I have to actually put parentheses around the x minus 4 because that whole thing is y. That whole thing is going to become negative. I'm going to keep the rest of my equation the same. But now, in order to solve, the first thing I need to do is distribute this minus sign or this negative sign because the whole y is negative. So it's actually going to be a negative x, and it's actually going to be negative and negative, a positive 4. Now the rest of this problem you will solve the same way, but that little trick at the beginning is going to make it a very different answer if you forget to do that. So make sure you use parentheses when you're substituting, especially if there's a negative sign out front, or if this was like 2y or 3y, you would have to distribute that number in front. Okay, so let's keep solving. We have a negative 3x. And I got x equals 3. Now I'm going to plug that into one of my original equations. Again, choose the one that's easier. The first one is definitely easier here. So I'm going to choose that. I have y equals x minus 4. I'm going to put in 3 everywhere that I see an x. My ordered pair then is 3, comma, negative 1. Check this in your original equations. If I plug those back in, will it work? So if I put in 3 minus 4, I would get a negative 1. And if I put in a negative 1, that would be a 1, minus 6, I would get a negative 5. So you can show that check step to make sure your answers are correct.